Hi, this is Irv Shapiro with the Dr. Vax channel. And today we're going to look at how to go from this really relatively ugly print. I'm not sure you can see because it's printed in white how ugly it is, but there are clear layer lines. There's an enormous amount of ghosting. There's this terrible seam right here, right across the front. The back is fair, but more ghosting and artifacts. And then I have this version where there is no seam at all on the front. It's much harder to see the layer lines. There's a little bit of ghosting where I go from the transition of printing two object areas to one, or from here to here. But overall, this is quite a beautiful print. So today we're going to learn how to go from one to the other. And if you want to learn both the concepts involved and the particular Cura settings, then stay tuned and let's learn something together. Now, before we get started, don't forget to subscribe to the channel and click on the bell. Share these videos with everyone you know, because that helps the channel and inspires me to produce lots of additional videos where my goal is to simplify technology concepts so more and more people can use technology to make things. When talking about quality in 3D printing, I'm reminded about a classical philosophical concept. And this concept is described both by Confucius and by Aristotle. I'm going to use an example from Aristotle's representation of this concept. It's called the doctrine of the mean. Now, Aristotle uses it to describe the idea of balance in becoming a virtuous human being. But I'm going to take his example and then apply it to 3D printing. The example that Aristotle gives is that of a soldier in a war. If the soldier has too much courage, then perhaps they'll take risks, they'll make bad decisions, and they'll die. If the soldier has too little courage, they'll be a coward. They'll run away from the battle and face repercussions. So a soldier needs the right amount, the right balance of courage. In the case of 3D printing, if you want the very best quality, it's going to take longer. So this print was a 6-hour print. This print was a 3-hour print. But even more so, there's a third concept that applies, and that's to strength. The more plastic, in the case of FDM printers, that you lay down as part of a print, the stronger it'll be. As an example, many of you may have printed a model in vase mode. In vase mode, you're telling the slicer to create a print where there's only a single layer of plastic. Those prints are quite beautiful. They print very, very fast. They're very, very weak. This model, I can't really flex very much, a little bit, but not very much. This was printed in traditional mode. If this had been printed in vase mode, I could have easily bent this model. So on the one hand, we have quality. As you raise up quality, you're going to lower your speed and potentially reduce the strength of your model. Now, let's look at this slide for a second. There are two phrases on this slide: filament flow and nozzle positioning. Everything summed up, and there are many, many parameters in Cura, but everything sums up to these two concepts. The smoother the flow of your filament, the more continuous the flow of your filament, the more consistent the flow of your filament, the higher quality print you obtain. That combines with the ability to move the print head to a precise location. And while the print head is moving, ideally, you want no filament flow. Filament flow while the print head is moving causes stringing. So our ability to control these two characteristics of your 3D printer will go a long ways towards determining the quality of your print. And in the future, as you look through 100+ parameters in your favorite slicer, think about the impact on filament flow and positioning. Now, if I break down the key parameters we're going to look at today, I can divide them across these two categories. So in the area of filament flow, I have layer height, temperature, speed, travel, retraction, and combing. Now, in fact, some of these parameters impact both, because in terms of positioning, the first item is speed. The faster you ask your printer to move, the more likely there'll be vibration in your frame, vibration on the table it's sitting on, the inability of the printer to precisely place the nozzle where you want it. The faster you attempt to print, and this is not obvious to a lot of people, the more difficulty your printer, your 3D printer, will have in extruding a precise amount of filament. Likewise, for positioning, you have travel, retraction, combing once again, build plate adhesion. Well, this also might not be obvious. But when you think about it, if your print moves at all on that build plate, you're not going to be able to precisely position that print. One reason for significant layer shifts, which cause lines in your print, is both the inability of your printer to manipulate the build plate properly, but also if your print is not solid on that build plate. We're going to look specifically about how to eliminate these seams and the impact both on slicer settings and on model orientation. And we're going to look at a mesh fix parameter, a parameter a lot of people may not know about, that will help your printer print more smoothly by printing less small segments. If your printer has to print very small segments, every time you have to reposition that nozzle, it makes it harder for your printer to extrude a smooth line of filament. Now, let's look at this next picture and understand a little bit about how 3D printers work. And this might be a review for a lot of you, but once again, thinking about the mechanics will help you set your slicer parameters more precisely. On the left side of this picture, we have a Bowden-style 3D printer. So you have a roll of filament. The extruder pulls the filament off that roll or reel of filament. It pushes it through a long tube called a Bowden tube into the hot end. Now let's look at that hot end a little bit. The green section of that hot end includes both a thermistor that will measure temperature and a heating element. And that's where the filament is actually softened or close to melting. That softened or melted filament is pushed into the nozzle. The black area with fins above the heating element is called the heat break. Because if we have soft or melted filament moving back into the Bowden tube, we won't be able to control extrusion properly. So you want the filament soft in the green area and below, and not soft above that. Now, if we are printing faster, the extruder has to turn faster. It has to push filament into that hot zone. It has to melt and come out the nozzle. The ability to melt the filament is dependent on both the volume of filament pushed into that hot zone and the temperature of that hot area. So if we want to print faster, we may want to increase our temperature. But if we increase our temperature, when the filament comes out the nozzle at the end, it's going to be hotter, it's going to take longer to cool off, and it's going to cause more stringing. We're back to the doctrine of the mean. On the right side, you'll see a direct extruder printer, which has the advantage that it does not have that Bowden tube. The extruder pushes the filament directly through the heat break into the hot end, and so there's more precise control. And in general, direct extruder printers are often faster. Now that's interesting because there's more weight being moved around because the extruder's on top of the hot end versus being somewhere off on the side. But in general, at least in my experiences, my Prusa, my Quiddy, and my Ultimate 2, Monoprice Ultimate 2, are all faster than some of my other printers. Now, in addition to the parameters we're going to concentrate on, there's a whole range of parameters that directly impact the flow of your filament. Cura assumes if it tells the printer to extrude X volume of filament, that's exactly what's going to happen. It assumes every printer is in essence perfect, but they're not, and they're not even close. Now, there are a couple ways to tune the extrusion of filament. The primary areas that you're going to tune are the ability of your printer to hold temperature. That's called PID tuning. There are videos on the channel about that. In addition to tuning temperature, it's also important to tune the extruder. How much should it turn each time it needs to extrude filament? Now, you can tune that in the firmware itself, and there's a video on the channel on that, but you can compensate for an imprecise extruder by just changing values in your slicer. So on the screen here, you'll see that you can set the overall flow rate, the wall flow rate, the infill, the skirt, the top-bottom flow rates. If you make this number bigger, then your slicer will attempt to compensate for an imperfect extruder by pushing out more filament. If you make it smaller, it will push out less filament. Now, how do you determine what to do? Well, you take a model. This is called a calibration cat. There are many calibration models available on the web. I'll provide a link to this one. And this is supposed to be exactly 20 millimeters by 20 millimeters. So you print one, and then you take either a ruler or a caliper. Obviously, a caliper will be more accurate. And you can see here it's somewhere between 19.8 and 19.9 millimeters on this side. Pretty darn good. And on this side, it's also about 19.8. Now, if this is off by more than, let's say, 5 or 10%, you should probably change the extruder flow percentages in your slicer. Let me show you the formula for figuring that out. So you'll see on this screen, you take the expected measurement. In our case here, that's 20 millimeters. You divide it by the actual measurement. You multiply it by the current extruder multiplier. That'll generally start at 100. And when you solve this algebraic equation, and I know algebra is scary to some people. It was scary to me for many years, but then I married a woman with a master's in math, so I had to learn algebra to survive our marriage. When you solve this problem, you'll see that it comes up with 108 in this set of examples. So I'd fill in 108 as the top number, if you look at this slide, overall flow. Now, I might want to fine-tune the other independent values. That's probably a discussion beyond this video. So now, assuming you've checked your flow rate, let's look at the other parameters right in Cura and discuss how I would adjust those to go from this model with a terrible seam and lots of defects to this model, which is really quite good. Now, if you look at the screen, This is what Cura will look like if you first open it up. You have no ability really to tune anything other than to set your layer height and your infill percentages. So the first thing I'm going to want you to do is click on Custom. Now, that's going to show you more or less parameters depending on another very important setting. So the next thing I'm going to do is click here and click on All. That will allow me to see every parameter in Cura. Now, yes, there's a lot of parameters in Cura, but they all really relate to controlling flow and positioning. And let's get to it. We're going to start with quality. The first difference between these two models is this model, because I wanted it to print very fast, was printed at a 0.3 millimeter layer height. This was printed at a 0.16 millimeter layer height. Now, why does that affect quality? Well, higher layers, fewer layers, but you'll see them more. But as importantly, it means your printer has to extrude more filament. The more filament over a given amount of time you ask your printer to extrude, the more likely your quality is going to suffer. However, this particular model did print very fast. It's printed in 3 hours. This took double the time. So the first thing I did is I reduced the layer height. I made no change to infill. I left it at 15%. That might seem light, but this doesn't have to be very strong. It's just used to hold a remote control that I then Velcro to the wall behind my bed. So 15% worked just fine. Material. I initially printed this first one at 190 degrees Celsius because I find that on this particular printer, this is a Caddy X Smart, which is a middle grade printer, not the best printer I have, not the worst. In some ways, I really like it. It's easy to use. It does string a little bit at higher temperatures. I looked at this model and there's not a lot of possibilities for stringing, so I increased that to 200 degrees. Why? It'll make it easier on the extruder to push filament through the melt zone. Next, this fast print was printed at 100 millimeters per second. Now, acceleration and jerk control will actually impact that, so I'm not going to get a true 100 millimeters per second, but I wanted this to print fast, and it looks like I printed it fast. This one was dropped down to 60 millimeters per second. I find generally printing at 30 to 40 millimeters per second is the highest quality speed I can get out of any given printer. Travel. You need to make sure retraction is on for quality. You need to fine-tune your retraction in order to minimize stringing. I had no stringing at all on this print, and so retraction is properly tuned here. Now, in addition, there's a parameter down here called combing. Now, if you're on the current version of Cura, you don't really have to mess with this. The default now is not in skin. What combing does is when you go to print and then stop and travel to another spot to print, you normally do a retraction. You reduce the pressure on the nozzle by pulling back a little bit of filament. Now, it's not actually going to pull filament out of the nozzle. That's melted. But it's going to reduce the pressure. However, that takes time. Now, on a direct extruder printer like this one, like the Caddy X Smart, probably not going to reduce a lot of time because you're only retracting about 1.5 millimeters. On a Bowden style printer, let's say an Ender 3 version 2, you might be retracting 5, 6, 7 millimeters. It's going to take time. So combing says when I'm moving inside the model in a place that I've already printed, where it's going to be in the infill, I'm not going to see it, don't bother retracting. I don't care if there's stringing. The problem with that is, as you get close to the top of your model, if you have those strings under the top surface of your model, it will cause a little bit of bumps. You'll be able to see it. I'll show you a picture of that here. If you say combing not in skin, that says retract, even if you're printing over an area already printed, if you're close to the top, the outside the skin of the model. And that'll improve your print quality. Next, and I skipped over support because that's another topic that has to do with overhangs. Many of you have watched other videos about that. There's a lot of good material on YouTube about that, including in my channel. Build plate adhesion. You want to make sure this doesn't move at all. So if I'm printing something really critical with a small surface area, this has a pretty big surface area, I will turn on a brim. Now, there are really three options here. There's skirt, brim, raft. A skirt is just a line around the outside to start your printer flowing the filament properly. A brim is actually a lip printed around your print that will help hold it to the print bed. There's nothing right underneath, but it's right up against the edge and it sort of forms a lip around it. That's the option I normally select. A raft is actually print something, a flat surface underneath it, put your print on top of that. The problem with rafts is sometimes they're a little harder to remove. So build plate adhesion is important. Next, let's go down to mesh fixes. And I'm going to put a picture on the screen because we're going to look at maximum resolution and maximum deviation. 3D printers cannot print circles. They always print line segments. Line segments might be very, very small, almost dots, but they're printing dots and line segments to form a curve. The more individual segments it prints, the smoother the curve. But the smaller the segments, the more your printer has to work to position for all those positions. Each time it repositions, it potentially could leave a bump. I'll show you a picture here of a terrible example of a very bumpy print that I solved by changing the number of segments. The way you change the number of segments is you set maximum resolution to a larger number. The default is, I believe, something like 0.5. It used to be 0.15 in earlier versions of Cura. I often change it to 1 millimeter. When I ask Cura to use longer segments by setting maximum resolution higher, I have a way to say to Cura, don't do it if it's really going to change the shape. And that is, I have Cura measure the deviation from the original shape. And if that deviation is larger than the maximum deviation, then it won't make this optimization. So if we go back to here, we'll see that I have a maximum deviation of 0.05 and a maximum resolution of 1. Those changes taken together allowed me to go from this print to this print with one other important change. Let's look at seam. So I'm going to go up here to the search box and type in seam. And we can see seam alignment, seam position. Seam position is set to the back. Now that would be a good idea because you don't want a seam on the front. In this particular case, I'm taking and attaching it with Velcro to a wall or to my nightstand. I wouldn't see a seam at all on the back. In fact, seam was already set to back when this first one was printed. So let's look at what's going on here. So I have here my model. I'm going to take and slice it, and it'll take just a moment or two. And you'll see that with these settings, it'll take 6 hours and 31 minutes. Let me look at the preview here. And now you'll see it's going to go around and start printing. And see where the green line started? It's going to come back to that spot each time. That pause, that spot where the green line was positioned, is this seam right here. And I don't know if you can see it, but it's a very pronounced seam. Now, I showed you earlier that I told Cura to put the seam on the back. Why is the seam going there? Now you're looking at Cura from the front. And you'll see that this is what Cura thinks is the front. So Cura didn't know that that's going to attach to a wall. It thought this was the back. So what I want to do here is I'm going to go to rotate, and I'm going to rotate this around 180 degrees. There we go. Now, the back is truly the back. So let's reslice this. Go to preview. And now we'll see it's starting the outer perimeter in the back on this side. So the solution to this problem was actually not changing where Cura was going to put the seam, because I already had it set to back. It was reorienting the model. Well, folks, I hope you learned something today. You learned that you can print beautiful models on pretty much any 3D printer by adjusting parameters, increasing temperature a little bit, and slowing it down. Or you can print fast models by increasing the speed, increasing the layer height. Thanks so much for watching. If you enjoyed this, give me a thumbs up, subscribe to the channel. Most importantly, if you want to discuss these concepts or others, there's a group of almost 1,000 viewers of my videos at forum.drvax.com, and they talk about all the videos after I publish them, and more importantly, it's just a really good group of people that help each other out. So go to forum.drvax.com and let's continue to learn things together.